This is the 9th episode from the Organic Chemistry 4th semester. Here I come up with the 2015 question of stereochemistry. Stereochemistry has been discussed in your organic syllabus, 4th semester syllabus. I tell you one thing, that's very important topics for the competitive examination. Let us discuss a couple of questions from that topics. I just selected this one. The structure of 2s3r2n 2-amino-3-hydroxybutanoic acid. Okay, you know this is called the Fischer projection. How do you name the Fischer projection? In the Fischer projection, vertical line is the parent carbon chain. Vertical line is the parent carbon chain. And the topmost group will be the highest priority group. We know that. We know the glucose structure, Fischer, CHO, OHH, and CH2OH. This is a glucose. You know, this is a vertical line and parent line, and CHO must be at the top position, because when you draw Fischer projection for more than one chiral center carbon atoms, the highest priority group, highest priority group means among this function, or in the functional group, highest priority functional group should be the topper. Well, that is one criteria. Okay, anyway, when you name, and another one in the Fischer projection, these cross points are optically active. Cross points are optically active. If there is 4 cross points in glucose, it has 4 chiral centers. Cross points are chiral centers. Okay, in a Fischer projection, each cross points represent each chiral center. Here how many chiral centers? 2. Here how many? 4. Okay, point number 2. In Fischer projection, cross points are chiral centers. Okay, now this I said here, this is a word parent chain. Therefore, when you number 1, 2, 3, 4. 2-amino-3-hydroxybutanoic acid. 2-amino-3-hydroxybutanoic acid. Now the problem is your second and third positions are chiral position, chiral centers. Therefore, you should know what is their RS notation. That should be also represented. That is our next task. If a Fischer projection is given, suppose you have a Fischer projection, okay, VRH. Here how many chiral centers? Only 1 chiral center. Why? Because there is only 1 cross point. If a Fischer projection given like this, how do you identify its RS nomenclature? Very simple. You find out the groups. Please mark the atoms directly attached to the chiral center. It's a carbon. This carbon is attached to chlorine, iodine, H, and bromine. Which is the most highest atomic number here? Iodine. Therefore, it gives the number 1. Now, which is the second most highest atomic number? Bromine, 2. Third, 4. Now, you just draw likely 1 to 2, 2 to 3. Therefore, 1 to 2, 2 to 3. This one. Okay. Now, this is a clockwise. If it is clockwise R, don't write. If it is clockwise R, anti-clockwise S. Don't write. Now, this is clockwise. It is R. I wrote here R. Now I have to check. Is this fourth group on vertical line? If this fourth group on vertical line, the configuration is R. Then only you write the configuration R. R. Fine. Yes. I just write another example. Another example. Okay. Iodine, hydrogen, bromine, then chlorine. Yes, I start number. I use atomic number for this. 1, second. This is third. This is fourth. I just draw 1 to 2, 2 to 3. This is anti-clockwise, not S. But before finalizing, where is fourth? Is it on vertical? No, it is on horizontal. Therefore, the S turn to R. This is a correct. This is a correct. You know why? Hydrogen on horizontal. Okay. If hydrogen is here, if hydrogen was here, you can select as you got it. If hydrogen on horizontal line, please invert whatever you got by the direction. That's only pointing out to extra remember. What is extra point you have to remember? If the hydrogen on horizontal, please invert the configuration, whatever you got by direction. ഈ ആരോ മാർക്ക് വഴി കിട്ടിയത് എന്താണോ അതിൻ്റെ ഓപ്പോസിറ്റ് ആണ് നിങ്ങൾ എടുക്കേണ്ടത് എപ്പോൾ ഹൈഡ്രജൻ ഹൊറിസോണ്ടലിലാണെങ്കിൽ. ഓക്കെ, ഓർ ഫോർത്ത് ഗ്രൂപ്പ് ഹൊറിസോണ്ടലിലാണെങ്കിൽ. In hydrogen, don't think that always it is hydrogen. The fourth group should be on the vertical. Otherwise, you select. The final is whatever you got. The opposite of whatever you got. Fourth group vertical ആയിരിക്കണം, അല്ലെങ്കിൽ നിങ്ങൾക്ക് ആരോ മാർക്ക് വഴി കിട്ടിയതിന്റെ opposite ആണ് final result. Okay, now we can go to another example. Some critical examples. Okay, I give you another one. OH, NH2, CH3, CH2, CH3. Okay, what are this is a chiral carbon. Chiral carbon atoms attached to the chiral carbon O. ഇവിടെ O ആണ് എടുക്കേണ്ടത്, OH അല്ല. O, you select the atom attached to the chiral carbon. Here you select the carbon. Here you select nitrogen, here you select the carbon. Okay, first you select like. Among this, which has the highest atomic number? 1, 2. Now when you come to here, you have a problem. Can you make both the same? No, both are carbon. Then, if both are same, then you go to these hydrogen, hydrogen, hydrogen. Here what are attached to this carbon? Hydrogen, hydrogen and this carbon. That is, this is nothing but H, C, then H, H, H. Therefore, this carbon is containing H, H carbon. The sum of this atomic number is 3, sum of this atomic number is 8. Therefore, this is third, this is fourth. Therefore, 1, 2, 3, 4. 1 to 2, 2 to 3. Hydrogen, the fourth group is on the vertical, no problem. Whatever you got, it is anti-clockwise. Anti-clockwise, this is S. Okay, simple. Now we can go to another example, very, very critical example. Very critical example. Very critical example. CH3, CH2, CH3, CHO, COOH. What are the atoms directly attached? Carbon, 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 carbon. 4 atoms directly attached. Both are same. Therefore, what you go to our rust groups. Here you know C double bond OH. Therefore, what are the 3 atoms attached to this carbon? Oxygen, oxygen H. Why I took 2 oxygen? Because this is a carbon, this is a group. This carbon attached oxygen H, again oxygen. Here are 3 hydrogen H, this 3 hydrogen. Here we know that H, HC. Now come to here. What is this group? C double bond OH. Therefore, what are the groups attached here? Oxygen, oxygen, oxygen. Because COH. This oxygen 2 times. Tell me, here oxygen, oxygen H, 3 oxygen, 3 hydrogen. Therefore, this is the maximum priority. Number 1, 2 oxygen. Number 2, carbon and hydrogen, 2 hydrogen, 3, 4. Therefore, 1 to 2, 2, 2 to 3. 1, 2, 3. 4th group on vertical, therefore no problem. This is clockwise. Am I correct? Clockwise. The pointer of the clock rotates like this, clockwise. Therefore, these are very simple. Okay, with this preface discussion, let us go to the question. Okay, here a little this. Okay, we can go. First, we can discuss, identify this nitrogen, carbon, hydrogen, here a carbon. Am I correct? Nitrogen, carbon, it has the first priority because nitrogen. Here carbon. But here around the carbon, you have 3 oxygen. Am I correct? Here around the carbon, oxygen, carbon and hydrogen. Therefore, it has second priority. Obviously, since it is hydrogen, it has the third priority. Therefore, 1, 2, 3, 5. But hydrogen on horizontal. Therefore, opposite. What is this? This is S, but actually is R. The S turned to R. Why? Because of this hydrogen. Please remember, because of this hydrogen, S turned to R. Okay. Therefore, here 2R, not 2S. Now, this is not correct. Okay, let us take, because 2 should be S. That's our molecule. We can save the type, otherwise you will be confused. Okay, now come to here. If I check, if I get the R, if it is R, it is not correct because we need 2S, 2R. It is 2R. Therefore, this is not the correct. Now let us come to here. Nitrogen, carbon, here carbon, because hydrogen. First is go to this one. Second goes to here. Okay. Obviously third. 1 to 2, 3. Am I correct? 1. Second priority for this. Third priority for this carbon. 1, 2, 3. This is R. Am I correct? But the hydrogen on horizontal. Therefore, the opposite. The R should be S. Okay, S. Okay, now let us check this one. This is our carbon, oxygen, carbon, here the carbon and hydrogen. First goes to oxygen. Okay, because highest atomic number. Now here carbon, this carbon, around this carbon 3 hydrogen, but around this carbon, hydrogen, carbon, hydrogen. Therefore, second will go to here. Third will be here. Okay, students, 1 to 2, 3. This is also R because clockwise. Because the hydrogen on the word horizontal, this is also turned S. Therefore, 2s3s. No, that's not correct. We need 2s3r. Now let us go to here. Okay, 1, 2, because 3, okay, are turned to s because hydrogen on the horizontal. 1, here carbon, this is the 2 because this carbon has more priority than this carbon. 2, 3. At present, it is S because it's an anti-clockwise. Am I correct? Anti-clockwise. But this S turned to R. You know why? Because this hydrogen, the fourth group, on the horizontal. Therefore, 2 is 3R. This is the correct answer. Okay, let us check this one very quickly. 1, 2, 3. Anti-clockwise. S turn to R. S turn to R. You know why? This is S that turned to R because of this hydrogen. That's also wrong. Therefore, C is the correct answer. Practice will make you to get answer within 1 minute. I think this topic is clear. We will come up with more questions from stereochemistry in the next episode. Thank you for watching.